Lily,
and cannot
What?
be removed.
you poked my arm.
I'm
Don't
sorry.
poke the bear.
Do not.
The machine.
Let's just say it's gonna be weird. The square root of. Wait. I can't say negative x because then x can be a negative. I want to make it so it's always going to be the square root of a number. That's negative. So, how would I do that?
I don't know.
Ooh. Ooh. Ooh.
So you might want to do. So what you're trying to do, actually,
Yeah.
I think what you're going to end up doing is making a function that has no domain, basically. What I want you to do, don't worry about writing a function definition. I want you to draw a graph, just some x and y axes. Okay. Now, draw a function on there. So now, the easiest way to graphically know if you've got a function is this thing called the vertical line test, which means that any vertical line only intersects it once. So I want you to draw something that is in fact a function, but that you are required to pick your pen up for, and that there would be no way to fill in the gap with just a dot like we did before. Okay, so far so good?
Oh no.
Actually, that works.
That works.
That works. You've just drawn a function.
Yeah.
Okay, we've got a discontinuity
Good job,
at
Cooper.
x0, and there's no way a single dot would fill in that discontinuity, right? I could,
Thank you, Pen.
for 0, I could say that this is my function value. I could have a dot there and an open hole here. Or I could do the reverse, right? I could define the function so that this is my dot and this is my open hole, right? So my 0 is even in the domain of each of those. However, there's a discontinuity there because I was forced to pick up the pen, and there's no way a single dot will remove that discontinuity. So this discontinuity is, do they call it non-removable? Yes. And there is no E in the end, that means
Unable to be fixed.
Another fairly straightforward example of a non-removable discontinuity is the one we saw over here with 1 over x.
But you can't. There's no way you could connect
There's not
those.
even a way to simply define. I mean, you could give a value at 0. You could say, okay, this function is 1 over x, and x isn't 0, and I don't know, it's pi, and x equals 0. You could define it so that 0 sits in the domain of that function, but all that does is put a dot, on the axis somewhere. It doesn't remove the discontinuity in any way. The discontinuity is still going to be there because of this asymptotic behavior.
Ooh, asymptotic. That's a good word.
It is a